You can see my chat GPT, you can see my screen, you can see Discord channel. If anyone wanted, hi guys, welcome to High Entropy. So it's day 56 of DSA learning, and I'm showing up every day. So don't forget, if you wanted to be part of this family, then you can subscribe me. I'm so sorry. Like I don't want to I don't want to sound like a bigger, but I feel like I'm sounding like a bigger. Okay, by the way, forget about it. That's joke apart. So if you wanted to connect over Discord, then I will shared you the link. Okay, let me go to the Discord. Let me go to the stream, see if everything is working. And welcome to High Entropy, by the way. Okay, so I created one Discord channel today because I saw like people are using Discord beautifully for learning purpose. So if you wanted to connect, you can connect me. I'll see what wanted. Let me go to the stream. Okay, I don't know. My stream is very lagging. It's a network issue, I believe. Okay, so I created one Discord channel today. Let me type some messages. Welcome to High Entropy. Will do that. Okay, nowadays I'm just planning like to respond like when someone. Okay, yeah, and if you wanted to be let me type some messages. Part of family. Hi. Entropy. You can join our Discord server. Yeah, if you by the way, anyone if you wanted to join, like I don't know how to. I think I need to use Streamlab. It will be better. So right now I'm not using, but maybe soon will start using that. I'll get chat. But I just want to focus on one thing at a time. Remember, whatever you are doing, do one thing at a time. Otherwise, you will be confused and your efficiency will be down. Okay. Take you forward is taking time to open. No problem. Open, man. I think it took it very seriously when I said it is taking time. Okay. After it, we definitely will jump into the graph. I know there are some other topics, but we'll jump into the graph because I never solved the graph. Maybe one or two problems I solved, so I just wanted to finish it first. I don't want to stuck into the tree linked list and all other. We'll see them later. I know I think recursion, linked list, graph. So we'll cover graph first, then we'll go to the linked list, recursion, stack. I think then we'll go to the tree. And there is tries, right? I never tried to solve the problems of tries. Okay, is this gesture is also working? So let's jump into the dynamic programming problems. Okay, so shine cookies. Let's see what kind of problem it is exactly. It's a dynamic problem, DP, dynamic programming problem. I think I'm DP problem, dynamic programming, dynamite. Okay. Hello. Hola. Haiku. I always used to say Heroku. I think there is some deployment. Oh man, it's taking time. I don't know how my stream will work. If here I'm getting lag, it will be killer. I hope. I don't think it will work properly. This is also a problem with this. It's not good at all. Come on, man. Wake up. It's very slow. Guys, I don't know what should I do of this internet. It's a stupid internet not working properly. I think I need to switch to Airtel maybe. Let's see if it won't work for some more time, then I will switch to Airtel because I'm paying. What is the benefit of if I have to struggle for internet? Right, if we are paying for service, then we should get proper service. You are not giving it for charity. You are taking money for. So if anyone is wanna watch this video, especially from you. It could be user, or it would just inform to your upper management like what the shit you are spreading everywhere. Your services are very bad, though you have more subscriber compared, and you have like you have market capitalization, or what we say, market dominance, but the services are very bad, especially when you are living in city. And I think you can forget if you are living in village, then our services will be more poor, weaker. So consider a scenario. Let's jump into the problem, not the problems that are around us. Let's jump into the real problem, DSA problem. So consider a scenario where a teacher wants to distribute cookies to students. Okay, with each student receiving at most one cookie. Okay, given two arrays, students and cookies. Cookie students, given two array, student and cookie. The ith value in the student array describes the minimum size of the cookie that ith value in the student array describe the minimum size of the cookie that the ith student can be assigned. Okay, minimum size. The jth value in the cookies array represent the size of jth cookie. Okay, great. If cookie of I j, cookie of j is greater, cookie of j is greater than equals to student of I. Got it. Jth cookie can be assigned to ith student. Maximize the number of student assigned with cookies and output the maximum number. Maximize the number of students assigned with cookies and output the maximum number. Okay. 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 I mean, yeah. So let me recall it. We have a student array where student of I represents what is the minimum capacity or minimum, as maybe you can think of like age, and based on that like what are their capacity of eating a cookie. So size of cookie they are mentioning it. So ith student can eat the students of I size of minimum. This is the minimum capacity of that student to eat a cookie, that particular size of cookie. How to say it? I mean, students of I represents the property about ith student, that this student can eat a cookie of size larger than, bigger or equals to the student of I, the capacity is written. Okay, so now the next thing is, okay, in the cookies array, cookie array, we have student array and cookie array. In the cookie array we have given different sizes of cookies, and if you wanted to assign a particular cookie, its size should be greater than a student of I if you want to assign to ith student. Okay, it sounds good. Now our goal is to maximize the number of students assigned with cookies and output the maximum number. Okay, so just first I have a question, like here the number of cookies will be greater than the number of students, or what? There could be multiple options, right? Okay, so our goal is maximize the number of, oh, I'm so sorry. I'm using this. So first thing, let me think more clearly, think out loud. So first thing, we have given student array, we have given okay, we have given student array, and we have given cookie array. Now not cookies cookie because it's array, so they are keeping like it's already plural, like there will be one or more than one, so you don't need to use students. It all depends on variable name how you are taking, no problem. So we have students. Now the first thing is we need to maximize the student. Okay, so if we talk, every student has how many options? If we see, like if you wanted to assign, so a particular student has j options. I mean, has how many cookies? If you are taking first cookie, if you are taking second cookie, if you are taking third cookie, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Okay, so first thing is, yeah, so every student has, yeah, let's say n option, n students and m cookies. So everyone has m options, out of which some will be possible, some will not be possible. So if you are considering that particular cookie, okay, then another will gonna explore all other options that that particular person has not taken. It's a simple problem, but it feels okay. Let me do one thing. Given to a student of I and cookie ith. Let me add timer, man. Why start 45 minutes? No problem. It's in the this mode. Okay. I don't think anyone is fine. No problem. Thank you so much. Okay, so show. Given two arrays, student and cookie, the ith value in the student array describe the minimum size of cookie that ith student can be assigned. The jth value in the cookie array represents the size of jth cookie if student and cookies maximize the number of students assigned with cookies and output the maximum number. So maximizing means what? If you assign bigger cookie to a person, then the problem is might be could be given to another person. So that's why you have to decide like whom to assign, so that you can assign maximum cookies to the students. Okay, let's think from cookie point of view. Forget about the students. Every cookie has two options. Either it will be picked or not picked. If it is picked, that means it will be assigned to some student. Cookie. Let me see the examples. Okay, constraints first. Let's see. No constraints. Oh, then there is 10 to the power 4. 10 to the power 4. Cookies length. Okay, it could be 0 up to. Student length can be like there will be at least one student, but cookie length can be, I mean cookie dot length, there are 0 cookies. Okay, it could be 0 at least. And cookie can be between 2 to the power 31 and 1. Okay, let's take example. I'm not getting it, man. 1 2 1 2 3. So let's call a student as 1 2 and cookie as 1 2 3. Okay, let's solve it. Another example, let me note down 4 5 1 6 4 2. 4 5 1 and C will be 6 5 2 6 4 2. 4 5 1 6 4 2. Okay, so here, God, I'm scared somehow about the problem. So C is cookie. Okay, 1 2 1 2 3. Okay, first thing, so you will check for first student. What are the possible options that you can assign to it. So for 1 you can assign 1, you can assign 2, you can assign 3. Then for 2, what I'm thinking, okay, so minimum will assign to minimum, second minimum assign to second minimum. You will assign it to the second minimum. Here if you see 4, it can eat 6. Okay, let's say 2 4 6. These are the sorted value. 1 5 4 1 4 5 1 4 5. Bro, S, see, we did like this because we don't need any kind of relation between this one and this one. Both are independent, and only it is like these are the different students and you can assign particular cookies. So now for 1 you can assign what? 1 has option 2, all the options like 2 4 6. 2 4 6. 4 has options 4 and 6. 5 has option 5 and 6. No, only 6. Now what I'll do, okay, so maybe I will do something like this. I will say okay. So we need to memorize it, but before memorizing, I mean, suppose if I will say like, okay, okay, let's do one thing. Let's build and build a tree. S 0 student 0 1 2. Let's say 0. You are at 0. First student. What is the students, right? So 0. You said okay. What are the options you have? So you will say look into the array. You have 2 4 6. So you will say what are the possible options that I can take. So you will start with 2. I mean you can take 2, you can take 4, you can take 6. All 3. So okay, you said no problem. If I'll take this, then how you will track like what has been already taken. This is a challenging part, right? Then you will go to 1. I mean yeah. So these are the different values that you can go. 1 1. What you took? You took 2, you took 4, and you took 6. So now what are the options you have right now? If you took 2, let's say forget about it, and suppose it took, okay, I mean it took 2, it took 4, it took 6. So if you are taking, you already took 2, then what are the different options you have? You can take 4 and 6. So you will say okay, now let me go to the 5. I mean you are at the student 1. So this student can take, it need 4 or 6. So it has two options. So 4 and 6. And where are we now? 2. And here if you think, if you are at 1 and you took 4, so now you have 2 and 6 option, out of which what are possible for 2. For possible for 2, it is not possible, only possible is 6. And if you are here, now you took 6. So for 2, not 2, only 6 possible. And for 2, if you are taking 6 at the starting, then from 1 what you can take? 6 you took, so you have two options. God, what I did. You have two options, either take 4 or you can take only 4. 4 only, you can take 4. And from here you can take 6. 4 and 6, you took 4 6. Now you will say okay, let's jump into the 5 2. From 2 you took 2 4. Now you have option 6, so you can take 6. So you will say okay, I will take 6 from here, and you will return. And from here you will say if you haven't took I mean yeah, okay, you have only one option remaining, 6. And if you took 2 and 6, now you are at 2 5. So you don't have any options. Same here, you don't have any options at the top only. If you took 4 and after that you have only option to take 6. Why do we need even this? So this is only the value that you can return, and this is only the value that you can return. And from here also you took 6. In the second option you took 4. So now you don't have any options like to return this, so you will return this. Okay. So what are the number of students you will say? From 1 you took 6, from 0 you took 6, and even here you won't be able to reach to 2. So you will say okay, you are getting 2 from here, 2 from here, and 4 6. Oh, what I did, man, getting 2 number of students, getting 3, getting 2, getting, okay, you just took this 2 and 6, 4 and 6, getting 2. So maximum you can assign students 3. 3. But how will I do it? I can draw recursion. How will I try what has been already taken from the previous branch? Let's imagine, okay, let's imagine scenario. You are at 0. You kept 3 flags. Okay, so what I'm thinking, I mean, every time we are going to explore the extremist part. I mean, you will go to this, then you will go to this, then you will explore it, and after that you will start from returning from it. And now, what are the options you have remaining? Uh, you will feel it like something like, maybe let's say, okay, so you will say something okay like this. You are taking 2. So no. So let's say, I mean, I think we can just do it with one array. Got. We have an array. So what I'll do, let me think from my angle what I can do. So these are the cookies. So cookies will be like 0, 1, 2. 0, 1, 2. Forget about it. So these are the array. So at starting, what you will do, you will consider first this one. So you will mark it as a true. Taken. I mean, true means taken. So, I mean, what are the values, bro? Okay. 2, 4, 6. You marked it true. Now you will jump into another one, and you will see, okay, these are the options available I have, 4 and 6. So you will say, okay, let me jump into this if I can take. So you will jump into it, and you will consider it. So you went from here, and you will jump into this one. So you took this, then you will say mark it as a true, and you will eventually get the result. I mean, you took 2, and now you will jump into this one, and you have taken for this one as well. So you will say, okay, for 2 I am taking, I mean, the second student I am taking true. So you took this one as well. Good. Now once you are returning something, I mean, you are over. Now you cannot get further. Either you don't have cookies or students are finished. All the students you have taken care, or cookies are over. Anything is possible. So once that is done, what you will start returning. So when you are returning, so what you took the last time, so you will mark that as a available. So now you have written this, and you came back to this location, so you will mark 4 also as available. And now you will jump into another option, that is 6, and you will mark true, and you will jump into it and return. But it's pretty hectic, bro. Every time you are doing this, okay, let's think about other corner cases. We don't have any assurance like, okay, cookies length will be lesser than or something. Okay, so it could be anything. So it could be like this one is students are more. So at each step you have to check what are the possible, you have sorted it, and when you are taking something you have to check, man. It's becoming a little complex for me. I'm just trying to solve it with some complex approach or what. So at each step, I mean maximum what can be 10 to the power 4 into 10 to the power 4 for each student. Okay, you are assigning a cookie, and for each student, checking the cookies array. Trying to get bro. I'm just doing something fishy. It's not possible. What is why sorting is necessary? What if there are more cookies than students? More cookies than students, then what? Maximum we can assign like to each student a cookie. So just we need to check like if we can assign something else. If it is not possible, all the possible options we will try. And once everything is filled, like everyone is taking cookies, then we don't need to further explore, at least in that particular branch. One of my hair, you can see it looking white, but it's not white, gray. What is the benefit of taking minoxidil and applying minoxidil if my hairs are still? And use one pointer to traverse the students array and another pointer to traverse the cookies array. If current cookie satisfies the current student, equipped it. Editorial I wanted to say. How many options are there? Memoization, optimization, tabulation. Well, I can see. What's wrong with it? Internet is not working or what? Hey, bro. IntelliPad 1 month ago. Is it working also or not? Hey, bro. It's working, right? By the way, resume, and I need to focus on it. Clueless, man. I mean, I know little bit about it. God, what went wrong? What is time right now? 9:39. What they should consider 1, 2, 4, 6, 2, 4, 6. I mean, what if we will sort both, start, will take 2 pointers. We'll start assigning like wherever the conditions are met. So we'll start from first cookie and we'll start from first student. Well, suppose both are not matching. Okay, so there are 2 options. This is bigger if student or cookie. If cookie, the student is its demand is bigger. I mean, it need bigger cookie. That means everything is sorted. So you cannot assign this cookie to anyone else because all will be bigger than or equals to this. Okay. That means we need to jump into another cookie. If S of I greater than C of J, then J plus plus. And now if suppose this is smaller and cookie size is bigger, so it might be like it's not possible for this, then all the cookies will be bigger. So we can say this cookie can be assigned to this one, or maybe we need to check. Else, if that is not the case, that means there will be 2 conditions: equal, assign it, and advance both I plus J plus plus. Okay. J plus plus. This cannot be assigned to it. Means it cannot be assigned to anyone. If S of there are two options: assign to it, you will assign it to this one. And what if there is another student whom it can be assigned also, the other whom also, but ultimately you will get one count only from anyone assigning to anyone. So will there be any problem, like if I will assign to it, it's a bigger cookie, so all the cookies will be bigger than this definitely. So if you are gonna assign it to this, I mean bigger or equals to, so if you can assign this one to this, if this is also possible. So let's say okay, I mean let's take example of 1 2 4 5 1 6 4 2 4 5 1, my voice 6 4 2. So these are the cookie, student, cookie, and now I need to sort them. So it will be like 1 4 5, and C will become 2 4 6. Okay, set initially I equals to 0, j equals to 0, and we have to say like while I less than this length of this and j less than this. So first time you will say okay, no problem, you will say okay, is this value C of j is less than, greater than, yeah, it's greater than this, bigger than this, so it can be assigned to this person. Okay, so what you will say, count will become count equals to 1, and you will assign 2 to this one. Okay, now okay, so now I will become 1, j will become 1. Now you will say okay, 4 and 4, can it be assigned to this? Yeah, you will say okay, it can be assigned to, so you will say no problem, count will become 2, count will be 2. Now this one you assign to this one, you will say okay, now 6 and 5, yes, you can say you can assign equals to 2, j equals to 2, and everything done, so count will become 3. And what about other 1 2 1 2 3? So you can get 2 1 2 3 1 1, so 1 2 3 1 1. I mean yeah, there also. So based on my observation, I think it's simply we can use 2-pointer approach. I equals to 0, j equals to 0, students as sort students. Why they kept capital letter, man? It feels like class name. S C equals to sorted. I mean yeah, sorted will be. I can use sort also to sort the same array. But let's take, I think yeah, it's be better. Short cookies cookie. So while I less than, okay, I haven't taken the length, n is equals to len of a student, and c, okay, m is equals to len of cookie, based on my thinking and Tarik, j less than n. Oh, so sorry. I mean I less than n and j less than m. If first thing, if s of I is less than no, cookie value is less than s of j. What the heck, bro, you are doing? Cookie represents I, j. So if this is the case, you cannot assign this to this. So what you will do? You have to move cookie. So j plus equals to 1. Okay. Elif. Okay, this is one condition. Second condition, what it would be? That means if it is not the case, so what is this? That means it would be c of j will be greater than or equals to this. So if it is greater than or equals to, then else you will say else I plus equals to 1, j plus equals to 1, and count plus equals to 1, and initially count will be 0, return c and d. Man, just I'm thinking like why they kept it in the binaries to confuse the people. Is it memoization technique? Is it really? Why they kept it in the memoization? That's why I see one thing here. God.
So the problem that we will be solving today is assign cookies.
Like it's easy for someone to manipulate if you are using another topic. At least for me, it's easy. As a beginner, like I'm not able to detect whether, like I was just thinking blindly, like okay, I need to use dynamic programming problem, DP, and I haven't tried to solve it from another angle. So it's a simple problem. Like you have to use two-pointer approach, but hey, bro, what the heck? You are unable to detect, you are unable to see if the problem is related to the GP or it is normal two-pointer problem. Minimum coins DP. But bro, it looks like why I think maybe it can be solved using dynamic programming DP also. So not sure why, but they kept it. DPS have so many problems. 10, 16, 16 and 7, 21. No, 23. And 23, 7, 30, 30, 32. 32 problems here and plus 2 to 4.5. So 5 here. How many shall counted? 10, 16, 16, 7, 23, 23, 32, 32 and 5. 37 problems total remaining in this section. And how many I solved? 5, 11, 6, 6, 6, 12, 12, 11, 12, 11, 23, 23, 24, 25, 26, 27, 28, 29. So still there. I mean, I took a lot of time to solve this problem, which can be. If anyone want to join, just join Discord. I want to connect with people definitely. Maybe let's see who will join. Yeah, I think let's draw one up. I will see you again in the next Yeah, let me take shower and go out. Bye bye. And today I just solved one problem, and the reason was simple. I'm dumb. Dumbest dumb. Dumba dumba. Hubba dumba. What do we say? Humba dumba. Bye bye. Okay, let's stop it, man. So here we go. We'll connect again. No problem. Oh, okay. Where is it closed? Can